So now we are going to look at oxidizing agent and reducing agent. So we want to identify oxidizing agent and we want to identify reducing agent, both. Okay, we want to identify both. So first of all, before you can identify what's an oxidizing agent and what's a reducing agent, you got to understand what the oxidizing agent does. What's the reducing agent do? So you got to understand that first. Then you look into your chemical reaction and then see which one is undergoing what in order for you to identify your oxidizing agent and reducing agent. So remember, oxidizing agents are substances. Okay, definitely they are reactants. So let me convert the substance to reactant. They are reactants because these two agents can never be products. Lock that up in your mind. Oxidizing agents and reducing agents are always the reactants. So if a chemical equation is given to you, do not look at the product side to design an oxidizing agent or a reducing agent. You are looking at the wrong direction. You're looking at the wrong position and location. All right. Rather, you're supposed to look only at the reactant. So if you have two reactants reacting, one of them is the oxidizing agent and the other must be a reducing agent. Which means, as what I told you before, in any redox reaction, there will be oxidation, there will be reduction. At the same time, in any redox reaction, there will be one reactant playing the role of an oxidizing agent, and definitely there will be another reactant playing the role of a reducing agent. An oxidizing agent can only react with a reducing agent. A reducing agent can only react with an oxidizing agent. Therefore, one cannot be without the other. So if you have an oxidizing agent in a chemical reaction, you must have a reducing agent. So one reactant has to play the role of an oxidizing agent. The other reactant has to play the role of a reducing agent. Capture all that in your mind. Okay? So coming back to that. What is an oxidizing agent? Reactants that causes, okay, another reactant. So you can say reactant 1 that causes reactant 2. You can also say that causes another reactant to undergo the oxidation process. Undergo the oxidation process. To undergo the oxidation process. That is why it's called an oxidizing agent. So let me capture that idea here. So you have reactant 1. You have reactant 2. Okay. So reactant 1 causes reactant 2 undergo oxidation. That means reactant 2 undergoes oxidation. So if reactant 2 undergoes oxidation, what do you call reactant 1? We call reactant 1 the oxidizing agent. Look at that. We call reactant 1 oxidizing agent. Why do we call reactant 1 oxidizing agent? Because it's an agent. It's a substance that causes reactant 2 to undergo oxidation. Definitely, that makes sense. Okay? So it definitely makes sense. So if I cause oxidation, so I must be the oxidizing agent. So does this cause oxidation? Yes, it causes the reactant to undergo oxidation. Therefore, reactant 1 must be an oxidizing agent. So that is well understood there. Okay, now let's shift our focus to the reducing agent. So what is a reducing agent? So using the same concept, reducing agent must be a reactant. Okay, reactant, so make it singular, reactant that causes another reactant to undergo what? To undergo the reduction process. The reduction process, again, makes sense. That is why it's called a reducing agent. All right? So if reactant 1 undergoes reduction, then it must be the reactant 2 that causes the reactant 1 to undergo reduction. It has to be. Because only 2 of them are reacting. So since reactant 2 caused reactant 1 to undergo reduction, reactant 2 must be known as the reducing agent. As the reducing agent. So that's your reducing agent because it causes that to undergo reduction. All right. Just spend some time, okay, understanding. All right, what is a reducing agent? What's oxidizing agent? What do they do? Okay. Now remember, a single reactant can only undergo one type of reaction during its chemical reaction. So if reactant 2 undergoes oxidation, definitely reactant 1 must undergo reduction. If reactant 1 is an oxidizing agent, reactant 2 must be a reducing agent. A reducing agent must react with an oxidizing agent. Reduction must go along with oxidation. Can you see? Now comes to the next question. How do we identify a reducing agent and an oxidizing agent in a chemical reaction? So the best way to identify a reducing agent and oxidizing agent is this reaction. Find out which of the reactant undergoes reduction. That's easier. So if a reactant undergoes reduction, what do you call that? Oxidizing agent. You see the opposite. If a reactant undergoes oxidation, then what role is it playing? What is its function? Reducing agent. Capture this in your mind again. A reactant that undergoes oxidation is the reducing agent, while a reactant that undergoes reduction is the oxidizing agent. All right? Okay? Take about 30 seconds. Capture that. All right, let's take an example. So let's say you have Na plus Cl2. All right? Okay, so you have 2 NaCl. Identify the oxidizing agent and identify the reducing agent. So based on this, I identify the oxidation reaction. That means which substance, which reactant undergoes the oxidation reaction. That will be the reducing agent. Which substance undergoes the reduction process, and that will be the oxidizing agent. So obviously, this is as oxidation state of +1, that as an oxidation state of oxidation state of 0, and that is an oxidation state of +1. Therefore, that has undergone oxidation. Remember, do not look at that. Although that's what you should need to inspect to find out which is always the reactant. So go back to the reactant. So sodium underwent oxidation. Therefore, sodium is the reducing agent. So if sodium undergoes oxidation, no need to think further. Chlorine definitely must have undergone reduction. All right. So since chlorine undergoes reduction, therefore chlorine must be playing the role of an oxidizing agent. So sodium metal is the reducing agent. Chlorine gas is the oxidizing agent. Conclusion. Okay, let's shift to another example. Okay, let me put it here. Okay, PbO, lead 2 oxide plus carbon, and the reaction is carbon dioxide plus Pb. All right, okay, lead 2 oxide plus carbon gives you carbon dioxide plus Pb. So of course I need to balance that. Okay, and that is balanced. Okay, anyway, let's look at the oxidation state. That's the easiest. Look at the oxidation state. So here your Pb as an oxidation state of 2 plus, your Pb as oxidation state of 0. This shows that it has undergone reduction. So since your Pb2 plus has undergone reduction, let's just talk about Pb2 plus. Therefore, your Pb2 plus must be, okay, reduction. It must be the oxidizing agent. All right, and this is accurate. Now in your SPM, if you were to say lead 2 oxide, they still accept it, but that's not accurate because oxygen doesn't play any role. I'll show you shortly what role oxygen plays. It is a lead that undergoes the reduction process, not the oxygen. Okay, all right, it's a lead. So Pb2 plus to Pb, it got reduced. Now meanwhile, if you check your carbon at an oxidation state of 0, but here carbon has an oxidation state of 4 plus. Therefore, it underwent what we call the oxidation process. So if it underwent the oxidation process, then carbon as an element, the carbon element is the the reducing agent. It's the reducing agent. Reducing agent. All right. Okay. Now, let us look at oxygen. What's the oxidation state of oxygen here? I've given you this before. It carries a charge of 2 minus. What about here? Also carries a charge of 2 minus. So do you see any change in the oxidation state? No. That is what we call a spectator ion. What does that mean? It actually doesn't take part in the reaction. How do you know it doesn't take part in the reaction? If it took part in the reaction, electron transfer would have occurred and oxidation state would have changed. But you can see the oxidation state remains the same before and after the reaction. As a reactant and as a product, you can see the oxygen is there in the oxide state, which is the 2 minus state, suggesting that no electron transfer occurred. That means the reaction is purely between Pb and carbon. So since that's the case, you can rewrite the reaction in the form of Pb2+. That means pulling out the reactants. That means the actual reactant here is the Pb2+. I pull that out, leave behind the oxygen. All right. Spectator ions can be cancelled out from our chemical equation because they do not play any role. We don't need to have them there. So you can rewrite and put that Pb2+. Carbon remains, and carbon dioxide, you can just put carbon with a 4+, okay, and you're left as 2 Pb. All right, which means you must have the 2 here to balance it out. Okay, and this would be the ionic equation. If you really insist on writing the ionic equation, that is how it will be. An ionic equation should be balanced from 2 aspects. One from the number of moles aspect. Number of moles, 2 Pb, 2 Pb. Number of moles of carbon, 1, 1. Therefore, from the mole aspect, it's balanced. And it should also be balanced in terms of the charge. Total charge on the reactant side, 2 times 2, 4+. Total charge on the product side, also 4+. Therefore, this is a correct ionic equation. That's the standard that you should attain, all right, when you learn all this. Okay, all right. So I've showed you how to identify oxidizing agent and reducing agent. Again, take a 1 minute time, get to absorb all this, process it in your mind, make sure that you understand carefully the method or the technique of how you approach this oxidizing agent and reducing agent in a chemical reaction.